Hello guys, so today we are going to solve k closest points to origin. So yeah, let's get started. It's a medium problem. Problem description states given an array of points where point I is xi, yi represented in the point of xy plane and an integer k, return the k closest points to origin 0, 0. The distance between two points on x and y plane is calculated by Euclidean distance. Might have studied in math. It's given by square root of x1 minus x2, the 2 points square, plus y1 minus y2, the y-axis of the 2 points squared. You may return the answer in any order. The answer is guaranteed to be unique. Okay, so let's go to an example. The first point states 1 comma 3 minus 2 minus 2 and k. The output is minus 2 minus 2 because it's closest to k. We can see it in the graph, and how it's calculated is based on the distance. For 1 comma 3, the Euclidean distance comes out to be square root of 10, while for second it's coming out to be square root of 8. And since square root of 8 is less than square root of 10, the second one is closest to origin, and that will be written. If we are to be written two smallest points or two closest points to origin from the points here, same thing would be calculated. Points length is always greater than k, and k is always greater than equal to 1, and the points are always as expected. So to start with, let's go with the Euclidean distance. Since square root of number, for example in here, the square root of 8 is less than square root of 10, right? So number 8 can be less than number of 10, so we don't need to calculate the square root. And another thing to notice is we need to find the closest point to origin. So our x2 and y2 will always be 0. So our Euclidean distance will be x1 square plus y1 square, and we don't need to calculate the square root. So how to solve this problem? To solve any k min or max problem, the standard approach is to use a priority queue. So priority queue uses a min heap or max heap depending on the type of solution. In here we will be using max heap because that will give us the maximum number or whatever that is within the queue, and we can pop that out so that we can have all the smallest numbers within our queue itself, which we can return. So standard approach is, if you have to find the smallest points or closest points, use a max heap. If you want to find the farthest points or maximum whatever, use a min heap. So let's get started in coding. We can use priority queue. I'm gonna have an int array because that's, and points are of int array. So by default it's gonna take min heap. So I'm gonna specify what I need to pass. So let's say if I have given 2 points a and b, I want the max first. So these are in order. So I want the Euclidean distance, how it's calculated, as I mentioned, to remove square root, and we don't need x2, so it's x1 square plus y1 square. So it will be and my points a and b both have 0 and 1 coordinate. The array 0th and 1 index represents x and y coordinate as given in points of I. So what I'm going to do is take b of 0 square. Oops. So I'm going to take b of 0 square plus b of 1 square. So this will be my first number, and my second number will be a of 0 square plus a of 1 square. Hope this makes sense so far. So if I give this good brackets, yeah. So what I've done is the numbers, if I've given a and b, I'm taking the Euclidean distance and want the max one to be stored ahead. That's why how this is working as a max heap. So once I have it, I'm just going to sort it against the array or the points array. So I'm going to say for each point in points, what I'm going to do is going to offer the point. So whatever the number is in the array, I'm going to add it in the queue. And now I'm going to check if PriorityQueue dot size is greater than k, because I want to make sure we only have the k smallest point. So if the queue exits the k points, what I'm going to do is I'm going to poll. So what poll will do is remove the topmost element from the queue, and how we are storing it is based on a max heap. So the furthest point will be on the top, and that will be removed here, and I don't want to do anything with it, it will just go waste. And that's how this loop is gonna run. For all points, I'm going to add it to queue, and if the size exceeds k, I'm gonna remove the topmost element so that the smallest k points will be stored in the priority queue. Once I have it, I'm just simply gonna create result new int of size k comma 2, because that's how the points are stored and I have k points. And then what I'm going to do is I can just say, yeah, I can just say while k greater than 0, result of k, I want to decrement it and then use it. I'm gonna pick the poll element and simply add it to the result. So it's gonna return me the topmost element from the queue, and then I'm just gonna return result. So what this is going to do is create a max heap of priority queue for all the points based on the Euclidean distance, loop through the points, for each point added to the queue. If the queue size exceeds the kth point or the kth closest, I'm gonna remove it from the queue itself. Once I have all the points looped, I'm just gonna create a result and loop through the queue to add it to the result and then return the result. So let's give it a run. Yep, so for the first one it worked just fine, and if I gonna submit, yep, that's how it works. So for time complexity and space complexity, the time complexity is gonna be n log k, because we are running n times for the points iteration, and the offer is gonna take log k time to perform, basically to find the maximum element to give it to us. So the time complexity is gonna be n log k, and the space complexity is gonna be O of k, because we are only going to store at max k elements in the priority queue. So the space complexity is way smaller of k. So hope this helps. give it a try, and maybe try solving a problem related to finding the furthest points from origin, and you might get some groove with priority queues. See you next time. Thank you.